प्रॉब्लम हो गया था कनेक्ट करने का। हाँ हाँ आप मैं बताता हूँ, फोन करके बताता हूँ। ठीक है ठीक है। हाँ हाँ आप रेडी रहिए, वैसे वैसे रेडी रहिए। ठीक है हेलो बोलो मैम। हेलो मैम चालू कर दीजिए। हेलो नंबर बोला था मैडम पण ते आले का ते? हेलो हेलो राहुल सर गुड मॉर्निंग। राहुल सर गुड मॉर्निंग मैडम।
Good morning, sir. Vishal sir, shall we start? We have to wait for some time.
No, you have to wait. Rahul sir has.
Hello.
Hello. Good morning, sir.
Hello. Am I
Hello.
audible?
Good morning. Yes, sir. So you are audible.
Sorry, I am facing issue with this audio. I am not able to connect audio.
Yeah, just fill up the. Hello, Rahul sir.
Hello. Am I audible?
Yes, sir,
you are audible. Ma'am, please start.
From phone, I am not able to join from my system. Not sure what is the problem in audio. Okay. So it is clear, right? Voice is my clear.
Yes. Yes.
Okay. There is a like I have joined from phone and my PPT.
Yes.
Can you enter?
Yes, Rahul sir, are you able to log in from your laptop?
No, actually, I am not able to connect audio option also, and the share screen is disabled.
Okay, share screen. Okay, just a second. I will give. Make a presentation. Now you can share.
Okay. I am still seeing it as a disabled. Can you pass host rights to me? Then
Sir, your two logins are same. So mobile or what?
yeah, I tried login out and then login again, but still this share option is disabled. Is there any other mechanism where we can join? Because this is not working, I guess.
Sir, in phone, please start share. Is it possible?
Pardon?
फोन में राइट दे दिए सर, आप एक बार चेक कर लीजिए.
Sorry.
Sushil sir, your
उसको
voice
होल्ड कर दे.
Can you patch me? I'm not able to see option. Maybe I can pass on the PPT and anyone can share on their behalf, and I can join the audio.
Okay sir, that is fine. So please share with me. I will share the PPT.
Yeah, just give me a second.
Okay.
Yeah, I have shared PPT. It should reach in a second.
Okay sir, let me check.
all participants, we will just wait for 2-3 minutes to sort out with this technical issue. Then we will start with our session.
Hello, am I audible now?
Yes, sir, you are audible.
Yeah, so I have joined from phone and I'm not able to see that share screen option. So anyone can share this PPT. That's fine.
Yeah. Sushil sir is sharing PPT from his system. You connect through
No,
phone.
I am not
Then,
able to get. I am not seeing the share option. So any one of you can share the PPT.
yes,
I
yes,
am
sir.
not
Yes,
able
sir.
to-
Yes, sir. We are doing that.
Sure.
हाँ? नहीं. Hello, ma'am.
Yes,
Hello.
PPT visible. Yes, sir. Presentation is visible.
Okay. Please start, ma'am. Please start.
Yeah. Okay. Good morning, Rahul sir.
Yeah. Good morning.
Yeah. So for today's, sir, I will give brief introduction, then you can start with it in a minute. Good morning, one and all present here. I welcome you all for the day 5 for FDP based on high performance computing using parallel, distributed and cloud computing. So for today's session, we have Mr. Rahul Dhote with us. He is from Persistent Nagpur. Currently, Rahul Dhote sir working as a engineering lead at Persistent System from 2018 to till date. Before that, sir was working as a module lead from 2015 to 2018, and before that, sir was working with All India Reporters. So, sir is having around 9 years of experience, and sir is having an experience with working on product development, stories of SQL over Hadoop products, integrated with Hadoop ecosystem like Hortonworks and Cloudera platform. He has also worked on integration of web-based SQL interface with SQL over Hadoop product. He is also having an experience with handling roles and responsibilities of lead big data engineer to develop new features, enhancements on the SQL on Hadoop product. While working as a module lead, he worked as a big data developer on big data platform to support SQL over Hadoop products on various platforms. Also worked on SQL over Hadoop products design and development stories on Hadoop platform. So I request you, sir, to start your session on big data analytics. So as per schedule, first session is from 10 to 11. And then next session is on Hadoop and MapReduce, which will start at 11:30 to 12:30 p.m. So if it is convenient to you, so we can continue till 12 o'clock, or we will do as per your convenience, sir. I request you to start with this session. Rahul sir? Rahul sir, am I audible? Hello?
Hello?
Hello, am I audible, sir?
Yes, you are audible. Is my voice audible?
Yes, sir, it is clearly
Okay.
audible. Please start with the session,
Okay. Sure. Yeah. Good morning, everyone. Yeah, this is Rahul Dhote. So basically, I have around 9+ years of experience in product development. So I have been working on Java ecosystem, big data ecosystem, and I have been designing and developing and delivering all these products in this 9 years, overall these 9 years. So I want to give an overview about the big data analytics. Basically, I think big data is a very huge topic. It is theoretically very vast and practically also very vast. So considering the scope and the time which we have, in the interest of time, I have tried to cover most of the basic things which we should know to enter into the big data analytics world. I hope it should clarify notions which we have in this big data analytics world. Yeah. Can you go to first slide? Yeah, next slide. Yeah, first slide. Back. One slide back. Yeah, that's it. So what is big data? So big data is nothing but the huge amount of data generated through various systems And this data is not for the storage, but we need to derive some good analytics from it. So when I say analytics, it is like the good results from it, the outcome from it. So big data is just not about the storage and just gathering the huge amount of data. It's about to gather data, process data, and then derive useful insights from that. This is all about the big data. Previous slide. Yeah. So what I thought, like, we can have an interactive session. We can dig more on the particular topic. So if you have, please feel free to interrupt me in between, so we can have interactive session and clarify all the questions, whatever you have. So types of data. So when we say type of data, it is broadly classified into 3 types: structured, semi-structured, and unstructured. Structured data is like all the data which we store in generally relational format in RDBMS. It is mostly structured. We have rows and columns. We can write SQL queries on those. We derive results from those structured data. Generally, structured data is stored in a RDBMS. Semi-structured data. So semi-structured data is like JSON, XML. So it is, we can say it is mostly structured, but we cannot directly query on that and get the insights. We have to first parse it, stored in a structured format, and then we can derive insights from it. So that's the type of semi-structured format. And then unstructured format. So unstructured format is like text files, PDF files, Office Excel files, log files. So these comes under the unstructured file. These files are like we cannot derive any conclusion from that data. Just it is a data. To derive conclusion, we have to first extract it useful information from it, stored in a structured format, and then we can derive a useful information from that. So considering the various types, so big data, these are the 5 types of data on these parameters we generally design the big data solution. So volume. So volume is very important. Generally, big data is meant for a volume only. Big data is not meant to store some MBs of data or few GBs of data. It should be more than 5 GB or 10 GB. Then it is better to have a big data system in place. If we have less amount of data, then ideally we should not go for a big data ecosystem, because that is already being handled by the RDBMS systems. From volume perspective, if I want to take few examples, so we have this Facebook, then LinkedIn, then Google. All those are working on a petabyte scale of data. Then there is a veracity. So veracity is, as I discussed, the types of various data like structured, semi-structured, and unstructured. These are the veracity of data. As per the veracity of data, we will require that amount of processing time to get the useful information from that particular data. Then we have velocity. So velocity, basically velocity is like, it can be divided into batch streams.
and real time. So when I say about batch, so batch is like something we have, like let's take an example. So I have Facebook data. So I generally used to post some, basically create some post in Facebook and store in database. So if I want to get the historical post from Facebook, so what I can do is I can retrieve the data in for a particular date range. So that is like a real-time data. Batch data is like we can process in a chunk format, and it is not real-time. We can create data at one period of time. Suppose I have a system which generates a data, for example, logs, and that logs can be analyzed in nightly fashion and maybe at a night time, and then we can extract useful information from that, derive results next day. So that is batch fashion. Real time is like once you store the data and then derive in analytics from it in a real time manner. That's real time. Streaming is like mostly the Netflix and Amazon Prime which we use generally. Those are the examples of streaming data. So on the real time, the video streaming, audio streaming. So this is type of example of streaming data. Then variety, I already discussed. Value. So value is a very important part. So basically, it is the goal whenever we design a big data system. The goal is to derive some value from it. Derive some good insights from it. So that insights will help in product improvement. Then we can add new features in existing products. So these are the basic. This is the basic intent to which we design the big data systems. Yeah. Any questions till now on this slide?
No, sir.
Okay. Next slide. Yeah. So scale of data. So as you know, like scale is very important. So from this slide, we see like Twitter generate around 5 million tweets per day. Then there is connected cars, then connected devices. Then there are 294 billion mails are sent in a day. So this is the scale at which data is now being generated. So to cater this and to basically get the insights from this amount of data, the big data ecosystem has been evolving. So this is the few examples through which we can get an overview like how much data is generated per day. Yeah, next slide please. Yeah. So far we have understood about the big data. So what is big data? What are the types of big data? And then we come to analytics. So since the notion it is big data analytics, so first we understood what is big data, what is the scale of data, what is type of data, how is the frequency of data, and then analytics. So analytics is like, it is just getting useful information from the data. That is the simple definition of analytics. So when we classify this analytics, so analytics is broadly classified into 4 types. Basically, descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So I will try to explain this using a simple example. So just a current example, so considering the COVID situation. So whenever we go to we visit a hospital, go to doctor to diagnose whether we are COVID infected or not. So firstly, he checks our O2 level using a pulse oximeter. So as we know, like O2 level, if it is less than 95, then there are more chances of infection. So he is able to determine like O2 is less than 95. So the device, the pulse oximeter which is showing this O2 level, that we can say as a descriptive analytics. Descriptive analytics is like what is happening, what is the current state of a system, or you can say what is the current state of that particular object. Similarly, if we consider an example of system, we can get the basic descriptive bar charts, then pie charts of various data. We can take any example. I just took this basic example of pulse oximeter, and then this when the doctor checks like whether the O2 level has gone below 95, then he prescribes. So to get your COVID test, get done your COVID test, do some chest CT. So that is diagnostic analytics. So once you get a descriptive and insight, you then move to the diagnostic. Yes, you do the COVID test or do the chest CT scan. So that gives a doctor picture like what is the diagnosis we have to do. So that's the diagnostic analytics. And once a report comes, either a COVID test report or a COVID chest CT scan report, he can predict what is the disease occurred in that particular human being. So that prediction is generally done by human. For currently, predictive analytical systems are being in our day-to-day life, but that are not that as general. But in future, it will be more general. So prediction is like deriving the result from your historical data. So when a doctor sees our COVID report and then he was able to see like you are COVID infected, that is prediction. Currently doctor does it, but if we have a system in place, like once the O2 level is gone below 95, and then automatically he predicts like whether it has a COVID infected or not. So that's the prediction. And then once it is predicted that you are a COVID infected, then what is the prescription? So basically, what prescription, what medicine should I give to cure this COVID infection? So that's the prescriptive analytics. So this is how the analytics is classified: descriptive, diagnostic, predictive, and prescriptive. So currently we are predictive analytics. Prescriptive analytics is being worked out. It is mostly in a research area. In general, we don't see many applications which are showing the prescriptive analytics, but till predictive analytics, we see multiple applications working on that. Yeah, any questions till now? Okay, we will move ahead. So we learned about big data and analytics, what is big data and what is analytics, and then combining big data plus analytics. So this is generally for cost reduction, adding new products and services in existing products, and making faster decisions. So this is the general goal of the big data analytics. Yeah. Next slide. So various technical areas, the scopes in which we can apply this big data, we can use this big data analytics. So big data analytics can be applied using cloud technologies. So we have multiple cloud available. Just for example, I will take AWS cloud services. So we can develop a system using AWS services to derive big data analytics for your particular use case. So we have many examples on which we have deployed this big data solution on AWS services. And this is the, we can say, a speedier way to deploy your big data solution on cloud. Any questions on this big cloud part, how big data analytics is work with cloud? Just feel free to ask any question. It will be good if it will be more interactive. No questions from anyone? Hello? Okay, I will move ahead. This is the big data analytics we can apply through cloud. Then there is a Hadoop. This is an operating system. Hadoop provide a complete ecosystem through which we can deploy your big data solution. It has a yes. Hello. Is there any question from anyone? Okay. So Hadoop provides a platform to integrate these big data components. There are various platforms from ingestion, processing, then there is basically reporting, and then we have security aspect also. So Hadoop provides completely ecosystem using few of the platforms available. Then there is a concept of big data lakes. So we can create a data lake for big data. These data lakes are, it's like any scale, like whatever scale you imagine, whatever data, whatever amount of data you have, you can scale up to that amount, more like petabyte scale. We have systems and tools available which can scale to petabyte scale. We have frameworks also to deploy those data lakes. Then there is other area through which we can use this big data analytics is predictive analytics. So predictive analytics is generally done through machine learning algorithms, and this machine learning algorithms basically process this huge amount of data in memory and derive insights from it. Then there are SQL over Hadoop. So SQL over Hadoop solutions are like you can query on Hadoop. Since Hadoop is a file system, we cannot directly query on it. To make it simple, we have SQL over Hadoop solution. So this SQL over Hadoop is like it has made easy for an end user to query on Hadoop data. Then there are NoSQL solutions. So NoSQL solutions, schema-less solutions, these can be scaled as Hadoop scale, and we can have searching on this NoSQL just for the good retrieval, basically query optimization part, and faster results. We can use NoSQL in place of Hadoop. And then there is a concept of deep learning. So deep learning mostly comes into the machine learning, but that is more advanced area in machine learning. Machine learning generally we use for predictive analytics, and deep learning is mostly to derive more better analysis, which is done through machine learning. Yeah, next slide. So, since I am mostly worked upon big data technology, I have covered less area for machine learning. So I will just give an overview how this machine learning works and what is the general paradigm used for machine learning. So this is the CRISP model. So this CRISP model covers complete machine learning. So these are the 6 phases through which every machine learning solution goes through. And beyond this, nothing happens in machine learning model. So why this machine learning has come? So this is like it is just not the deriving statistics. So statistics is being termed as a machine learning. Earlier we will derive statistics from your data using Excel and other statistical tools. Now the new notion has given as a machine learning. We have in a more typical way, we generally term it as machine learning. So we have a data set in machine data set. So data can be in any form. We generally have data in a raw format. So that raw data which is unused, which is not useful directly. So that is the first part where the data is there and it is not useful to us. First, we have to understand the business of that data. So what that data is about. So I will take example, any example. Let's take an example of patients only, healthcare only. So I have, suppose there is an Excel sheet which has 100 rows, with all the patient names and their phone numbers, their diagnosis, and their medicines what they have given. So this data, as an end user, that is not useful to me unless I know what type of patient is this, what the diagnosis has to happen on this, and what is the prescription we have given to this patient. So we have to first understand the subject of that data. So once I understand the subject of data, then I can think of what I have to do next with that data. So that's the first phase, business understanding. Then once I understand, yes, these 100 rows are related to the patient which are COVID infected, then their COVID test has came positive, that is one column in the data, and then we have prescribed it some antiviral drugs to that. Then. So now I can see like this is a COVID infected data and this is the basic information given for these patients. So that's the second phase, data understanding. Now this is completely in a row and column format. I want to segregate this data as in a sequential manner. Maybe when addresses are, since we have addresses in this data, we will segregate this data as per the state, city, and then area. We will segregate that data in this particular format, classify, we can say. So that comes under the data preparation. Once the data is classified, then this data is trained on the model. We start with the modeling process. So why we create a model? We create so this till the data preparation phase, around 70% of the time is consumed over this phase, and only 10 to 12% time is required for this modeling and evaluation phase. So this 12% consists of your machine learning part. Others comes under the big data part. So when I say modeling, so I have these 100 rows, and through this 100 rows, I should be able to generate new rows and predict the data, whether from the historical data, I should be able to predict whether the patient is COVID infected or not. So for that, first I have to train this data on the certain data set and make a model using it. So for the modeling, we have to use specific algorithm, like there are neural networks and all, lots of algorithms are there. We can apply those algorithms, and then we can evaluate this model by increasing the number of records in our data sets. When we find like there is accuracy, like accuracy is about 90 to 95%, it is able to predict properly, then it comes, then deployment stage comes. Once this model is stable, it is able to predict data properly, we move to the deployment stage. So this is cycle which is generally followed in machine learning model, and this is the CRISP model which is followed for deploying any machine learning solution. Yeah, next slide. Yeah. So for analytics, this is the general architecture followed, agnostic of tools and technology. This is the general architecture followed. So we have multiple data sources from which data comes. It is stored in a data warehouse. Data warehouse, as you know, like it should be scalable to terabytes and petabytes, and then derive dashboards and reports from that. And also, next phase would be the data science user, that's more towards the machine learning. So this is the common architecture followed to basically develop any analytics application. And we have sources, we have processing layer, and we have targets. Yeah, any question on this architecture?
So can you bit elaborate on the EDW as data warehouse?
Sorry, can you repeat me?
Can you please elaborate on the EDW, that is Enterprise Data Warehouse here?
Yes. So Enterprise Data Warehouse is Enterprise Data Warehouse comes in two solutions. One is like normal RDBMS part, and second is your Hadoop. So in RDBMS, generally in just few hours till 2-3 years or 5 years, we use generally RDBMS solution for data warehouse. So we know like Oracle, MySQL, and all these database vendors, these provide these data warehousing solutions. So these have some limitations in terms of storage of data. We cannot store data. There are some vendor lock-ins, and we have limits to store data. To overcome that, we have moved this traditional data warehouse system to Hadoop ecosystem. So in Hadoop, we can increase our data capacity as till to what at a scale which we want to know, we want as per our business requirements, and it is like pay as you scale, means we can scale as our data increases. So taking example of a Hadoop ecosystem, on AWS services, you can scale your data to any scale as you just have to increase the number of machines. As you increase your machine, and your storage capacity can be increased to any scale. So few common examples which are generally used in enterprise data warehouse are basically IBM DB2 BigSQL. Then there are basically S3 from AWS services. So these are the few examples which we use as an enterprise database data warehouse. Yeah, shall I move ahead? Yeah, next slide. Yeah, next slide. So various tools, platforms, and line. Yes.
Rahul sir, this is Rajesh Dharmik, Head Department of IT and the coordinator of this workshop. Simply I am interrupting you because most of the participants are not connected because of some technical issues. So simply wait for 2 to 3 minutes. We will send a new link to all the participants, and all the participants are connected through this new link. And then we will continue. Right? Hello?
Yeah, that's fine.
Hello?
That's fine.
And simply wait for 2 to 3 minutes.
Okay.
And also we are sending a new link to you. So then all the participants will connect with a new link. Right? Yeah.
Okay. Just please do it quickly because we have just 10 minutes.
Yeah. So stopping or you are continuing complete this also? So completing this current PPT? Yes. Rahul sir. Hello. Rahul sir, are you audible? Are you hearing me? Hello.
Sir, mostly sir has left the meeting.
हाँ मैडम वो क्या हो गया कि मैक्सिमम मोस्ट ऑफ द पार्टिसिपेंट्स आर नॉट ज्वाइन, तो उनको मैसेज आ रहे हैं ना, तो हम क्या करते हैं कि नया लिंक भेज देते हैं, उसके थ्रू सर भी ज्वाइन कर लेंगे, है ना, फिर कंटिन्यू कर लेते हैं।
Yes sir.
डिलीट किया।